Liquid penetrant testing or dye penetrant testing is a widely used planar defect identification (NDT) method. It is used to detect surface breaking defects with high sensitivity of up to 0.01 inches. Liquid penetrant testing has the highest sensitivity among all NDT methods for surface defects and is usually given preference over magnetic particle testing method. Liquid penetrant testing is a versatile method and can be used on mass production lines while also being portable. The type of defects that can be identified are cracks, seams, forging, lap joints, laminations, hot tears, cold shuts, undercuts, and porosity in cracks. The principle of liquid penetrant testing is based on the penetrant dye to seep into the defects by means of capillary action. First, the workpiece is thoroughly cleaned, that is pre-cleaning. After from this, the different types of penetrants which are available based on sensitivity, scale of operation, and defects to be identified, the penetrant liquid is sprayed on or dipped onto the workpiece. After giving the penetrant some dwell time for it to seep into the cavities and defects, excess penetrant is carefully cleaned using a solvent, emulsifier action, or water washing. Then the workpiece is sprayed, dipped, or blowed on with a developer material which brings the dye present in the discontinuities to become visible to the inspector and also acts as a color contrast. Based on the type of penetrant being used, the inspection is carried out under white light or in a dark room under UV light. The inspector then immediately starts recording the indications and based on the applicable standards like ASME Section 8 Division 1 and ASME Section 9 determines if the defects make the workpiece acceptable or to be reworked or completely rejected. Now, a question which comes to mind is whether LPT can be performed on all types of materials or not. LPT is a very useful surface defect identification method, but it also has its own limitations over the type of materials that it can be used for obtaining accurate results. Thus, LPT cannot be used on porous materials and should only be used on completely non-porous materials. This restriction is due to the way LPT works, that is, on the basis of capillary action of the liquid penetrant. If the material on which the penetrant is applied has porous surface, then in addition to the penetrant seeping into the defects, it will also get absorbed by the porous surface voids, due to which it will give rise to grossly inaccurate indications of defects. This is because the inspector will not be able to distinguish between the dye absorbed by the actual defects and the porous surface in general. For example, of porous materials are concrete, unglazed porous ceramics, and wood. Examples of acceptable non-porous materials are most metals like stainless steel, aluminium, nickel, carbon, steel, glass, dense plastics, etc. Further, LPT can also not be used on painted or coated metals as it would hinder the absorption process. Henceforth, before starting the process, the surface to be inspected has to be stripped of any paint and coatings. Thank you for watching.